When you see one of those absolutely colossal ships carrying energy across the ocean, it looks, well, almost routine, doesn't it? But what keeps that journey safe is anything but. There's this entire, unseen rulebook at play, a global standard of safety engineering that makes the whole thing possible.
I mean, really think about that question for a second. We're not just talking about a big boat. We're talking about shipping a liquid so incredibly cold it makes normal steel shatter like glass. And you're doing that across thousands of miles of open, totally unpredictable ocean. How on earth is that even possible?
Well, the answer lies right here, the International Code for the Construction and Equipment of Ships Carrying Liquefied Gases in Bulk, or, the IGC code for short. This thing is the master document. It's the global safety Bible that dictates every single detail, from the steel in the ship's hull to the training of its crew, all designed to minimize risk.
All right, so let's dive in. In this explainer, we're going to peel back the layers of this incredible code. First, we'll look at just how dangerous this voyage is to begin with. Then, we'll see how these ships are basically built to be unsinkable. After that, we'll check out the amazing ultimate thermos flask technology inside, look at the critical role of the people on board, and finally, see how this is all enforced with a global safety certificate.
Okay, first things first, let's set the scene. Transporting liquefied gas is, without a doubt, one of the most extreme logistical challenges on the entire planet. The cargo itself is incredibly volatile, and the environment, we're talking the open ocean, is completely unforgiving.
To give you a real sense of what we're dealing with, some of these gases, like liquefied natural gas, have to be kept at a mind-boggling minus 165 degrees Celsius. At that temperature, regular steel just shatters. This isn't just a shipping problem, it's a materials science nightmare.
So you can't solve this with guesswork, right? The IGC code is built on decades of hard-won, sometimes painful experience. It's a system that's deeply rooted in what the code itself calls sound naval architectural and engineering principles. Basically, a deep, rigorous understanding of physics, chemistry, and the immense power of the sea.
So how does the code actually tackle this immense challenge? Well, the very first layer of safety is the ship itself. It is designed from the keel up, not just to float, but to survive.
Now, the code is smart. It knows that not all cargo is equally dangerous, so it creates a rating system. A Type 1G ship, that's for the most hazardous products, has the absolute toughest requirements. Its tanks have to be located farther from the hull to protect against a collision. Then you've got Types 2G and 3G for cargo that's progressively less hazardous. It's all about matching the defense to the threat.
And what does tough actually mean in this context? It means the code literally forces designers to plan for disaster. The ship has to be able to withstand a major collision, control the flooding that follows, and stay stable even with the huge hole in its side. It's not allowed to tip more than 30 degrees, which is crucial for ensuring it won't just capsize in a worst-case scenario.
Okay, let's move inward, from the ship's tough hull to its very heart, the cargo containment system. This is our second layer of safety, and honestly, it's basically the most advanced thermos flask ever built by humanity.
Now look, you don't need to be a physicist to get what this slide is about. This formula, which is pulled right from the code, is just here to show the incredible level of scientific detail we're talking about. Every single stress on that tank, from the weight of the liquid sloshing around inside to the immense forces of the ship rolling in a storm, is precisely calculated to ensure total, absolute integrity.
And this slide, this really shows how that integrity is actually achieved. It's a super meticulous three-step process. First up, material selection. They use special nickel steel alloys that actually stay strong in that insane cold. Second, weld inspection. Every critical weld is x-rayed or scanned with ultrasound to hunt down flaws that are completely invisible to the naked eye. And finally, a brutal pressure test. Each completed tank is pumped up to 1.5 times its normal limit just to prove it can take the strain.
But you could have the best designed ship in the world, and it's only as safe as the people who are operating it. And that brings us to our third layer of safety, the human safeguard, which is all about procedures and training.
The IGC code really does think of everything. It specifies exactly what the crew needs to stay safe if there's an emergency. We're talking specialized clothing that protects against cryogenic burns, breathing gear with enough air for really complex rescues, and even decontamination showers right there on deck. It's a complete safety system just for the people on board.
So what happens if something goes wrong during that really critical process of loading or unloading? Well, that's where the ship's ultimate safety net comes in, the Emergency Shutdown System, or ESD.
It's basically a network of big red buttons and automated sensors that can stop everything, instantly. So how does it work? It's a pretty simple network of triggers and responses. As you can see, if a fire is detected on deck, bam, the system instantly shuts down all the cargo pumps. If a tank is about to overfill, loading stops automatically. And if a crew member hits that emergency button, valves slam shut and an alert is sent to the shore. It is all designed to contain a disaster before it can even really begin.
So, this brings us to our final section and our final layer of safety. How does this all come together? I mean, a rulebook is pretty useless if it isn't actually enforced, right? You see, the IGC code isn't some dusty old document sitting on a shelf. It's a living, breathing standard. It was first adopted way back in 1983, and it became mandatory just 3 years later. And as technology changed, the code changed with it, with a huge update in 2016. It's constantly being reviewed to make sure it stays ahead of the curve.
So how do we know a ship actually follows these hundreds of pages of rules? With this, the International Certificate of Fitness. Think of it as the ship's license to operate. To get one, and more importantly to keep it, a ship has to pass incredibly tough inspections. The certificate's only good for 5 years, and it requires annual checkups. No certificate, no sailing. It really is that simple.
And this quote, this really captures the entire philosophy behind it all. The commitment to safety never, ever ends. The code is specifically designed to learn from experience and adapt to the future, and that ensures that the next generation of ships will be even safer than the last.
So yeah, the next time you see one of those massive carriers on the horizon, just remember what you're really looking at. It is not just a ship, it's a floating fortress of engineering, a multi-layered system of survival, all governed by that invisible rulebook we've just been exploring.
And that kind of leaves us with a final thought, doesn't it? We've just peeked behind the curtain of one tiny corner of maritime safety, and it makes you wonder, what other invisible systems, what other silent rulebooks are out there, quietly and reliably keeping our incredibly complex modern world from falling apart?